Hello everyone, my name is Xinyi Chen. I extend a warm welcome to today's comprehensive exploration of indirect pointing devices. Over the next couple minutes, we will immerse ourselves into the realm of human-computer interaction, examining the evolution, applications, and implications of these transformative uh, technologies. But first of all, let's take a look at the agenda. Before we delve into the intricacies of indirect pointing devices, let us outline the journey that lies ahead. We will commence with an overview of traditional pointing devices and the emergence of indirect alternatives. Subsequently, we will delve into the various types of indirect pointing device, their real-world application, advantages, limitations, and culminate with a reflection on the future implications of these technologies. Pointing devices serves as the conduit between human and computers, facilitate seamless interaction and control. From the humble mouse to sophisticated touchscreens in iPad, these tools have shaped our digital landscapes. Yet, as technology evolves, so too do our expectations. The emergence of indirect pointing devices signifies a paradigm shift in human-computer interaction, offering novel avenues for engagement and accessibility. So, one may ask, what are indirect pointing devices? Um, at the heart of indirect pointing devices um, lies a fundamental departure from traditional input methods. Instead of directly manipulating cursors or pointers, users interact through intermediary technologies or devices. Usually they are hardwares. Consider, for example, eye tracking system such as the Tobii eye tracker. By capturing and interpreting eye movements, these devices empower individuals with disabilities to navigate digital interfaces with unparalleled precision and independence. Um, Indirect pointing devices encompass a diverse array of technology, each tailored to specific use cases and user preferences. Head-mounted displays such as the Oculus Rift transport users into immersive virtual environments, blurring the lines between physical and digital realities. Gesture recognition devices, exemplified by the Microsoft Kinect, translate hand movements into actionable commands, revolutionizing interactive experiences in gaming and beyond. Um, I have a very interesting personal experience with indirect point devices in game industries. I went to GDC and there was a session introducing how gestures can be um, commands in Apple Vision Pro for gaming, which was really interesting to see how the technology has really shifted. I've also read an article um, which uh, uses indirect pointing devices. I wasn't sure the exact name of it, but it takes users breathe as input um, to um, to tailor a feature in a game. For example, as user breathe and inhale, the character may just shoot and reload. So this also benefits the accessibility in gaming industry because imagine if uh, a person with inability to move the controller or mouses or any devices, you can just wear the indirect pointing devices that takes breathing as input and use breathing as a command to control the shooting. All right, let's go to the next slide. For slide 6, the applications and examples of indirect pointing devices extend far beyond entertainment and gaming. Um, it permeates diverse industries and domains. In the realm of healthcare, for instance, surgical navigation system usually leverage gesture control to enhance precision and efficiency in complex procedures. Similarly, in education, I also personally have some experience with that. Interactive devices such as like whiteboards or touch screens equipped with touch and gestures recognition capabilities um, help students with collaborative learning environments and forcing students to engage and to participate. Um, for now, I think touchscreen is a very commonly used device, very commonly used in indirect pointing devices among students to help with the learning. For example, iPads helps digital artists, help digital help digital artists and help art students to draw. And other students can use it to take down notes and search. However, the indirect pointing devices does have its advantages and limitations. For the advantages, we have the enhanced accessibility. For example, consider the eye gaze edge, an eye tracking system that enables individuals with severe motor impairments to control computers using only their eyes. This technology grants unprecedented access to digital interface, empowering users to communicate, browse the web, and engage in educational activities independently. FYI, Northeastern does have an immersive lab that provides various AR, VR, eye tracking technologies, which gives students the accessibility to all these equipments. So I suggest my audiences, if you guys have time and you are in Boston, you can access these technologies and experiences how they really are. The second advantage is improved precision and efficiency. The example could be for healthcare, as we stated in the previous slides, surgical navigation system equipped with gesture recognition technologies streamline complex procedures. Surgeons can manipulate digital image overlays with precision hand movements, enhancing accuracy and reducing operating times. Systems like the Da Vinci surgical system exemplify these advancements, revolutionizing minimum invasive surgery. And the last advantage that I can think of is innovative interactive experience. It is very evident that virtual reality headsets such as the HTC Vive, Oculus, Apple Vision Pro, they all offer immersive gaming experience that transcend traditional input methods. By tracking hand movements and gestures, usually users can explore virtual environments, interactive with objects, and engage in multiple player experience with unparalleled realism. These immersive approaches to gaming has redefined the boundaries of entertainment and storytelling. And as a person who majored in game design and game development, who has also had experiences with VR and AR development, I personally do like indirect um, pointing devices such as the VR headsets. However, for the limitations, the cost of the implementation usually comes with the enhanced access with the improved precision because all the devices are made usually to serve one single purpose. So while they offer compelling benefits, the initial investment required for the implementation can be prohibitive for some organizations. The eye tracking system, for instance, I was in the immersive lab, and the um, the student assistant that was working there told me that a single device could cost $10,000 for eye tracking. So it was extremely expensive because of the necessities of specialized hardware and software. Um, so the software is solely designed, developed just for to be um, to collaborate with the hardware. Um, Secondly, for the learning curve, it is not very user-friendly. Um, for my example, when I was in the immersive lab using the eye tracking devices, I took a couple hours to figure out how to put on the devices and to how do I properly use it without damaging it. It took a couple hours to get used to it and to get valuable data from it. The transition to indirect pointing devices, may entail a steep learning curve for users accustomed to traditional input methods, um, especially for elderly peoples who are already not that comfortable with digital devices. Uh, for individuals with disabilities, mastering new techniques such as eye tracking or gesture recognition may require time and patience and extra help. It may also require like extra development of the company to develop certain types of devices, indirect pointing devices, just to suit that case. So moreover, ongoing support and training are essential to ensure that users can fully leverage the capabilities of these technologies. The last limitation is the limited applicability in certain contexts. While the indirect pointing devices excel in specific use case, as I said, because they're designed to just function one or two purposes, they may not be suitable for all scenarios. For instance, eye tracking system may struggle to maintain accuracy in environments with variable lighting conditions, or for users with certain eye conditions such as nystagmus. Similarly, gesture recognition devices may face challenges in noisy or cluttered environments where precise hand movements are difficult to detect. By elucidating the advantages and limitations of indirect pointing devices with detailed examples, I hope my audiences gain a deeper understanding of the potential impact and considerations for implementation. These technologies hold immense promise for enhancing accessibility precision and interaction experiences, but carefully evaluate and planning are necessary to realize the full potential of indirect point devices. Uh, to summarize, as we conclude our little journey of indirect pointing devices, it is evident that these technologies represent a significant leap forward in human-computer interaction, from enhancing accessibility for individuals with disabilities to revolutionizing immersive game experience. The potential applications are vast and far-reaching. I invite my audiences to share your insights, questions, and reflections under the video as we embark the next frontier of technology innovation. I want to thank you all for staying till the last slide, and post any questions that comes to your mind. Thank you.